Sir, but
Sir,
your voice is low.
Okay, now is it okay?
Yes, sir.
yes, sir.
Fine. Okay. So we were discussing this numerical, and in this numerical, uh, you must have solved the summation of the forces in both the direction, that is x and y direction. So what exactly we have studied? First of all, we saw the different force systems, and we have understood that a force can be applied in any direction. It may not be truly vertical always. It may not be truly horizontal. It may be inclined also. So we have also seen one or two examples of how the inclined force may develop in any member or any structure. So based on that, we saw that such kind of inclined forces can be uh, uh, available with us. And whenever we try to find out the resultant of all such forces, and especially we were discussing about the concurrent type of force system. In concurrent type of force system, what do we expect? That all the forces are passing through a single point or one common point, right? So, how to evaluate the resultant of all the forces in order to calculate, in order to achieve that? So, what we do? We take the components of inclined force in x direction and in y direction. And this process is known as resolution of force. So finding out components is known as resolution of force. So what we have done, we have found out the components in x and y direction. Uh, Once we get all these components of the respective forces, then what we do, we identify in exact what direction these components are acting. Based on their directions, then we decide the positive and negative sign, or in short, we decide the sign convention. So what we have fixed, we will be very much adhering to the sign convention, which says that the horizontal force, which is acting in the uh, positive x direction, that will be, or if it is pointing towards right direction, that will be considered as the positive component of the force. And if it is acting in the negative direction or left side, then it will be treated as minus force. Similarly, the in the y direction, if the component of the force is acting upward, then it will be positive sign. And if it is acting in the downward direction, then it will be treated as negative sign. So these are the sign conventions based on which we decide the components of the force directions. Now what we do, resultant is the parameter which speaks about that quantity or entity which represents the effect of all the forces acting at that point, right? So this is what is the definition of resultant force for concurrent type of force systems. So what we did, we found out first of all the components of forces in x and y direction for each force, and later on what we have done, we have found out the summation of all the forces. So last time I had told you that in order to calculate summation of all the forces, you should be very much careful about the sign conventions. So summation of force in x direction will be F1x plus F2x plus F3x. However, the magnitude are positive, but in case of F2x, the direction is negative. So we need to take care of that. I hope you must have found out the values for Fx and Fy, summation of Fx and Fy. So can you please let me know what are those values?
Sir, Fx is 804 Newton,
Okay, and Fy,
282 Newton.
let us check. So Fx comes out to be 449 Newton, whereas Fy came to be 72 Newton. And uh, if we see this figure, whatever I have drawn, what do you observe? 449 Newton force. This summation of force in x direction, whatever has been found out, that came out to be positive, because of which the direction of the arrow is shown in the right side. Okay, understood? So I hope you all must have got this value. Is this okay?
Yes, sir.
If you want to verify, you can do it right now. See, 491 minus 400 plus 358. तो ये कितना होता है? 191 प्लस सॉरी 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 91, not 191. 91 plus 358. It should be 449. बराबर है? Similarly, if I want to calculate summation of force in y direction value, so F1x is plus 344. This is again plus 300, but here you can see this is minus 716. So the final value came out to be minus 72. ठीक है, minus 72 का मतलब क्या हुआ? The arrow should be acting in the downward direction, because we are speaking, we have calculated the value for force in the y direction. So y direction is maybe either upward or downward. So this is why this arrow has been represented in the downward direction. So this is the magnitude of summation of force in y direction, and this becomes the direction of that, right? But since force is a vector quantity, it should have a direction associated to it, final direction, right? And what we are doing, we are calculating the resultant value. So resultant will be only one value. Okay, so you can say that these are the components of resultant force. So how do we calculate this resultant R? What is the formula for this?
So under root Fx square plus Fy square.
Right. So it is R will be equal to under root of summation of forces in x direction whole square plus summation of Fy whole square. Okay. So if we take the square of these two terms and add them and take its under root value, you should get the value as 454.74. Please check it. You can verify this value. So once done, please let me know. ठीक है? Now this is the magnitude which we have found out, but there should be some direction. So how that direction is evaluated? The direction is evaluated by finding out the angle which is made by this resultant with the help of x-axis. Okay, so let me call it as theta value. And how to identify that theta value? Tan inverse of summation of force in y direction divided by summation of force in x direction. And from that you will get theta equal to 9.11. Please verify this. And please let me know whether these values, whatever I have found out, they are correct. ठीक है? Okay. Are you able to see this board, all of you?
Yes,
Yes,
sir.
sir.
Yes, sir.
ठीक है. So let us take up one more numerical, and in this numerical, please help me out because I don't have the final values. The final values are to be found out by you people. So am I audible to all?
Yes, sir.
Yes, sir.
Yes, sir.
ठीक है. So I will draw the figure related to the numerical. Newton. This force is F2. This is F4. Magnitude is 1000 Newton. This is F1 force. This magnitude is 780 Newton. And this is F3. 600 Newton. Yeah. So this is the given information. This is 30 degree. This angle is 30 degree. The information related to the angle for this force is given in this manner. Slope is given. Okay. 3 vertical and 4 horizontal. This is the slope for force F1. Right. So this is 4 vertical and 5 horizontal. This is another slope which is given. This angle is 45 degree. You are supposed to identify the resultant of this concurrent force system. Okay. So the problem statement is identify the resultant of concurrent force system as shown. Okay. So how to proceed? If you have understood the earlier numerical, so you can tell me step by step how to proceed and how to evaluate the resultant. So let's revise what exactly the resultant mean. What do you understand by resultant? The resultant, which is denoted by capital R, is nothing but it is the effect of all the forces which are acting on the system, and it will be represented by a single value. Since resultant is a force, it will be accompanied with a magnitude as well as direction. So that's why R mathematically is expressed as the summation of all the forces acting on a system, isn't it? So that resultant can be separated in other forms. See, because as you can see over here, all the forces, they are inclined forces. They are not straight forces. Straight in the sense they are not truly vertical and not truly horizontal. They are inclined, right? So in such cases of inclined forces, what do we expect? That there are components associated to it. That is force in the x direction and force in the y direction. So what we call them as components. Components. And in order to calculate these components, what do? We resolve the inclined forces. Resolve the inclined forces. Okay? Is this okay? And how do we resolve them? Now, for example, let me consider this force F1, and I wish to resolve the force which is inclined into two components. So how it has to be done? Like this. So this will form force 1 in x direction, and this will be force 1 in y direction. Is this clear?
Yes, sir.
Yes, sir.
So force 1 in x direction, this is the resolution of the component for force F1. This will be resolution of force F1 in y direction, and this will be in x direction. Okay. Now, how to find out the F1x and F1y value? So we know from our earlier explanation, I have told you that the x component shall be the F1 cos of, let me call this as, let's say, theta 1. I am calling this angle to be theta 1. Okay. So F1 cos of theta 1. Correct? So out of these two, how many quantities do you know? Do you know F1? Yes, it is given. F1 is 780 Newton. Now I wish to calculate this theta 1 because theta 1 is not directly given. It is given in the form of slope. So can you calculate that slope? Theta 1 shall be tan inverse of 3 by 4. Am I right?
Yes, sir.
So
Excuse me, sir.
please calculate this theta 1 value.
Sir. Sir.
Yes.
Sir, instead of calculating theta 1, we can simply calculate cos theta and sin theta.
Yes.
Instead of calculating theta 1, we can just calculate cos theta and sin theta. It would be easier.
See, we will go step by step. The reason being, for other forces, as you can see, other two forces are related to angle, that is 30° and 45°. So we will be consistent with it, isn't it?
Yes,
In
sir.
order to avoid confusion, that is what I aim for. Otherwise, you are free to do whatever mathematics you have studied and whatever shortcuts you know, that you can apply. But the thing is, I want that there should be kind of consistency, and therefore I am, emphasizing on calculating the theta value and then evaluating the further resultant value. So let's go step by step.
Yes, sir.
Okay,
So 36.67 degree.
Yes, sir.
36.67 degree. So find out, substitute rather, cos 36.67. So this will give me the value for fx. Now see, whatever I have shown over here, this is with respect to the magnitude. What should be the direction? So for direction, you please verify what is the arrow, what is the direction of this arrow, how it is facing. So from this figure, it is very clear that this arrow is facing on the right side of the x-axis. Okay, so this will be positive value. Am I right?
Yes, sir.
So what will be the final value? Please let me know.
So 624 Newton.
624.
Yes, sir.
624 Newton. Okay. I think all of you have got the same value. Similarly, evaluate F1y value. What should be F1y value? F1y value shall be F1 sine of theta 1. Theta 1 already you have evaluated. F1 you know. Only the thing will be now you are supposed to find out the sine component. That's it. About the direction, F1y is pointing in the upward direction and therefore this shall be positive. So I will substitute the values. You find out the final value. कितना था?
465
463.
or 465 sir.
468, sir.
How much?
So 468.
468.
So mine calculator is showing 465 sir.
Sir, it's 465.
अच्छा 465 ठीक है. ठीक है चेक करो उसको. 465. Fine. So what we have done, we have found out the components of force F1. That is F1x and Fy1. Here in our case, these two components came out to be positive. Why? Because both these arrows, they are directing towards positive x, and this is positive in the upward direction. So as per our sign convention, whatever we have fixed, we will stick to them, and based on that, this is positive and this is positive. That's why both these things are positive, right? So this is, you can say, step number 1, step number 2. Likewise, you are supposed to identify for the next force. Let's say F2 force. So for F2, what you do? You resolve this force into components. How to do that? This will be F2x. And how will be the direction of F2y?
So downwards.
Downwards. Great. So this will be downward F2y. So you can see there is a consistency in the arrows also. Right? Now, I will rub this. Okay. Now I will calculate the components F2x. F2x. What should be the value of F2x? For that, let me consider this angle to be, let's say, theta 2. Okay, slope दिया हुआ है 5 horizontal 4 vertical, right? So what will be this value? F2x shall be F2 cos component होगा, sin component होगा, क्या होगा?
फिर cos component.
Cos of theta 2. I know what is F2. I need to find out theta 2. Theta 2 can be easily found out by using tan inverse of 4 by 5. Am I right?
Yes, sir.
Yes
कितना
sir.
था वो?
38.66 degree.
38.67,
66.
let's say. Is this okay? All of you please verify.
Yes sir. Yes sir.
ठीक है. Now substitute the values. F2 कितना है? 2000 cos of 38.67, let's say. What is the direction of F2x? It is acting in the positive x direction. So therefore this will be positive. What will be the final value? Please let me know.
Sir, 1561.51, sir. 1561.51.
1561.
0.51.
Okay, 1561.5 Newton. All of you please verify this,
Yes, sir.
and this will be positive.
Yes, sir.
Okay, good. Now F2y. F2y again, F2 sine of theta 2. And now while finding out this F2y value, be careful because this is acting in the downward direction. Since this is acting in the downward direction, this shall be negative. And therefore substitute 2000 sine of 28.67. कितना था वो value? And this will be negative.
Sir, 1249.66 minus 49.66.
Okay, let's say 1250.
Yes, sir.
1250 Newton. Okay, and the direction is negative. So these are the values for F2x and F2y. Now it is very easy for you people to solve these things. That is F3 and F4. There is no, there won't be any problem as far as F4 goes. Force F4 goes because this is 45 degree. Calculation will be very easy, right? This will be F4x and this will be F4y. About this, the resolution for F3, it will be like this. So this will be F3y and this will be F3x. This angle is actually 30 degree. Okay, so you can consider this angle or you can even consider this angle. It is up to you. So let us consider this angle. So if I consider this small angle, this will be 30 degree. Do you agree or not? Do you agree? This is F3y and this F3y is what you can say forming a base for F3. This is inclined and this is vertical. So angle between these two forces shall be 30 degree. Am I right?
Yes, sir.
Okay. So if this is 30 degree and if I want to expand the equation for F3y, what I should write? F3 into what should be the value? Cos component or sin
Cos.
component? Yes, it will be cos. So let me say cos 30 degree. Correct? Although it is y component, so in earlier equations you must have observed that for y component it was sine. But over here it came out to be cos. The reason is very clear because this this F3y component is forming the angle with this inclined force. So it will be F3 cos 30 degree. And how is the direction? It is upward. So therefore it will be positive. Okay. What is the magnitude of F3? It is 600 Newton. 600 Newton cos of 30. This will be positive. How much does this come out to be?
Sir, 519.6.
How much?
519.6.
519.6. Newton. And similarly, F3x. Okay, how is the direction of F3x? Negative x. So minus F3. Now this component shall be sine minus 600 sine 30.
300.
300.
Yes, 300 minus 300 Newton. Can you quickly find out the values for F4x and F4y?
So minus 707.10.
Yes, yes.
It comes out to be minus 707.10.
Minus 710.
707.10.
Acha, 707.1
10.
Newton.
Same for F4Y, sir.
F4y will be same because of that 45-degree angle.
Yes.
But for that you should be very much careful about this sign. Okay? In this case, both the signs are negative, right?
Yes, sir.
So fine, very good. So what you are supposed to do? You are supposed to identify the resultant of all these forces. This is what is the question. But for that, what we have done, we have resolved everything into components. And as far as resultant definition goes, it is nothing but under root of summation of all the forces in x direction whole square plus summation of y direction forces whole square. This is what is the definition of resultant. In order to achieve this, firstly what we will do, we will calculate summation of force in x direction and summation of all the forces in y direction. So be careful while calculating these forces. I hope you have noted down all the values. You please let me know what will be the values. Okay. So summation of forces in x direction will be F1x plus F2x plus F3x plus F4x. Tell me one by one. F1x कितना था?
624, sir.
620. Positive. Positive.
Positive, sir.
ठीक है. Then F2x
1561.5, sir. Positive.
1561.5. It was again positive. F3x
Minus
Minus
300.
minus
300, sir.
minus 300. And what about F4x?
Minus 707.10.
Minus 707.1. So these are the values. You please calculate all these summation values.
Sir,
Is there any-
1178.41.
Yes, how much?
1178.41 positive.
1178.4.
One.
And this is positive, I suppose.
Yes, sir. Positive.
ठीक है. Similarly, summation of forces in y direction. F1y, F2y, F3y, F4y. Substitute the values. F1y कितना था?
465.
465.
Yes, sir.
Positive.
Yes, sir.
Then
Positive.
F2y, it must be negative. How much was the value?
Minus 1250, sir.
1250.
1250.
Okay. F3y, positive. How much?
519.61.
519.6 something plus F4y, it is negative. How much?
707.1.
707.1. ठीक है, करो कैलकुलेट. This I think it will come out to be negative. I think so.
So minus 971.89.
Okay, minus 971. Please check all of you. Right. So meaning of this is whatever summation of forces in x direction we have calculated, those came out to be in the positive x direction. So I will plot that. Summation of forces in y direction, this came out to be negative, that means downward. I will write down the values also. So these are whatever arrows I have shown, these are nothing but the representation for direction. Okay. I will now write down the magnitude. 1178.4 Newton. And this is 971 Newton. So what you can say, these are the components of a force, right? X component and Y component of a force. Now what you are supposed to do, you are supposed to find out that force for which these components are formed. So let me say this is that force, and I will call this to be resultant. Correct? So as per the definition and mathematical equation, this is the resultant value. Simply calculate that value. Under root of 1178.4 square plus 971 square. How much does this come out to be?
Sir, 1526.6.
Acha, 1526.6. Others, please also verify.
Yes, sir.
Yes, sir.
So if it is okay, this is one part. This is what? This is the magnitude of this force, resultant force. Now you are supposed to identify the direction. Let me call this to be theta angle. And that theta angle shall be represented by tan inverse of summation of forces in y direction divided by summation of forces in x direction. So I will write it down. Y direction, summation of force in x direction. Substitute proper values and find out theta.
Sir, 50.5 degrees.
How much?
50.5 degrees, sir.
60 or 50?
5050.
Acha, 50.5. 50.5.
5, yes, sir.
Okay. 50.5 degrees. Others, please verify.
Yes, sir.
Okay. Fine. So if all of you have got these values, so that is
नहीं sir wrong हो गया sir.
what it should be.
So 40 के आसपास आएगा.
हाँ
नहीं,
sir,
आसपास नहीं,
3.50 ही आया ना.
sir
Exact
39 आया sir. वो
See the
एक सब आया, sir.
tan inverse of.
39.
See what you are supposed to find. Tan inverse of y direction में कितना है ये? 971 divided by 1178.4.
So 39.35.
39.35.
35.
Okay, 35. So this is how the resultant of concurrent force systems should be evaluated. Now see, this is one type of numerical. You will find variation for other numericals. So we will see what are the other variations and how those are to be solved. For that, we need to consider few under what we can say some background related to the understanding of solution of these numericals. So we will see that from the next class onwards. Okay? So was this okay?
Yes,
sir.
sir.
I hope the board is clear. I mean the display and all.
Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
sir.
Whenever you find any kind of difficulty, please let me know. I will try to solve it. Okay? ठीक है. Thank you very much.
Thank you, sir.
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 Thank you.